Firstly, gather evidence. Obtain the manufacturer's specifications and certification documentation for the transformer. Review project plans and blueprints to verify that the transformer meets the specified requirements. Document any conversations or correspondence with the manufacturer regarding the underwriter's laboratory's listing issue. Secondly, consult with an expert. Engage a licensed electrical engineer or qualified inspector to review the evidence and assess whether the transformer meets the applicable codes and safety standards. Obtain a written report from the expert stating their findings and conclusions. Thirdly, review codes and standards. Determine the specific code requirements in your jurisdiction for transformer installations. Refer to the National Electrical Code, ANSI/NFPA 70, and other relevant codes. Interpret the code provisions carefully, considering the context and intent of the requirement. Fourthly, analyze evidence. Compare the transformer specifications to the code requirements and manufacturer's documentation. Examine the expert's report to determine if the transformer meets the applicable safety standards. Consider any exceptions or variances that may apply to the installation. Fifthly, prepare a defense. Based on the evidence and expert analysis, prepare a written defense outlining why the transformer approval was not negligent. State the specific code requirements that you believe were met and explain how the transformer complies with those requirements. Address any potential arguments or objections raised by the authority having jurisdiction. Sixthly, present your case. Present your defense to the authority having jurisdiction in writing or during a meeting. Provide supporting documentation and evidence. Be prepared to answer questions and discuss your reasoning. Consider the potential risks and consequences of operating an unlabeled transformer. Explore the possibility of having the transformer nationally recognized testing laboratory labeled to satisfy the authority having jurisdiction's concerns. Document all communication and actions taken to mitigate the issue. It is important to approach this situation with professionalism and a willingness to collaborate with the authority having jurisdiction and other stakeholders. The specific steps and actions required may vary depending on the circumstances of the case. The National Electrical Code Section 450.3 covers the requirements for transformer overcurrent protection. Depending on the voltage and the transformer size, specific overcurrent protection requirements will apply. The primary and secondary conductors must be protected in accordance with their ampacity per National Electrical Code 240.4. Proper grounding and bonding are crucial for safety. National Electrical Code 250 provides detailed requirements for grounding transformer enclosures, the transformer neutral if applicable, and the secondary system. Check National Electrical Code 250.30 for specific grounding requirements for separately derived systems. Transformers must be installed in accordance with National Electrical Code 450. This includes requirements for ventilation, clearances, and accessibility. Ensure adequate ventilation to prevent overheating. Follow manufacturer's instructions for installation and maintenance. Verify that the transformer specifications such as voltage rating, kilovolt ampere rating, and impedance meet the project's requirements. Confirm that the transformer is suitable for the intended application and load. Consider the ambient temperature and environmental conditions at the installation location. Transformers installed in high-temperature environments may require dirting or additional cooling. Ensure that the transformer is protected from physical damage. Install barriers or enclosures as necessary to prevent damage from vehicles or other equipment. Keep detailed records of all inspections, tests, and maintenance activities performed on the transformer. This documentation can be valuable in demonstrating due diligence. Consult with the transformer manufacturer or a qualified engineer for guidance on specific installation or maintenance requirements. Adhering to manufacturer recommendations can help ensure safe and reliable operation. Review the transformer nameplate data to verify its ratings and specifications. Ensure that the information on the nameplate matches the project requirements and documentation. Before energizing the transformer, perform installation resistance tests to verify the integrity of the windings. Use a megometer to measure the resistance between windings and ground. Check all connections to ensure they are tight and properly torqued. Loose connections can cause overheating and potential failures. Verify the transformer's polarity and phase rotation before connecting it to the electrical system. Incorrect polarity or phase rotation can damage equipment. After energizing the transformer, monitor its operating temperature and voltage levels. Check for any signs of overheating, unusual noises, or other abnormalities. Periodically inspect the transformer for signs of oil leaks, corrosion, or other damage. Address any issues promptly to prevent further deterioration. Ensure that the transformer is properly labeled with appropriate warning signs and identification information. This can help prevent accidental contact or misuse. When performing maintenance on the transformer, follow lockout/tagout procedures to ensure that it is de-energized and safe to work on. Use appropriate personal protective equipment, such as gloves and eye protection, when working on or near the transformer. If the transformer is located in an area subject to flooding, take measures to protect it from water damage. This may include elevating the transformer or installing flood barriers. Consider the potential for seismic activity and take measures to secure the transformer to prevent damage during an earthquake. Regularly inspect the transformer's cooling system, including fans, pumps, and radiators, to ensure they are functioning properly. Clean or replace filters as needed to maintain adequate cooling. If the transformer is equipped with a liquid-filled cooling system, periodically test the oil for contaminants and dielectric strength. Replace the oil if it does not meet the manufacturer's specifications. Ensure that the transformer is properly protected against lightning strikes. Install surge arresters on the primary and secondary sides of the transformer. If the transformer is located near flammable materials, take measures to prevent a fire. This may include installing fire-resistant barriers or sprinkler systems. Develop a comprehensive maintenance plan for the transformer that includes regular inspections, testing, and maintenance activities. Follow the plan diligently to ensure the transformer's continued reliable operation. Keep spare parts on hand for critical components of the transformer, such as fuses, bushings, and cooling fans. This can help minimize downtime in the event of a failure. Provide training to personnel who will be working on or near the transformer. Ensure they are familiar with the transformer's operation, maintenance requirements, and safety procedures. If the transformer is nearing the end of its service life, consider replacing it with a new, energy-efficient model. This can improve reliability and reduce energy costs. Before disposing of an old transformer, properly remove and dispose of any hazardous materials, such as oil or polychlorinated biphenyls. Follow all applicable environmental regulations. Conduct a load flow study to ensure that the transformer is adequately sized for the intended load. Overloading the transformer can cause overheating and premature failure. Consider the impact of harmonics on the transformer. Harmonics can cause overheating and reduced efficiency. Install harmonic filters if necessary to mitigate the effects of harmonics. Ensure that the transformer is properly coordinated with the upstream and downstream protective devices. This can help prevent cascading failures in the event of a fault. If the transformer is part of a critical system, consider installing a redundant transformer to provide backup power in the event of a failure. Regularly test the transformer's protective relays to ensure they are functioning properly. This can help protect the transformer from damage in the event of a fault. Keep a record of all transformer settings, including tap settings, relay settings, and overcurrent protection settings. This information can be valuable in troubleshooting problems or making adjustments. If the transformer is equipped with a remote monitoring system, regularly review the data to identify any potential problems. This can help prevent failures and extend the transformer's service life. Consider the potential for vandalism or theft and take measures to protect the transformer from these threats. This may include installing security fencing or alarms. Regularly review and update the transformer maintenance plan to ensure it remains effective. This can help keep up with changing conditions or new technologies. Consult with a qualified electrical engineer for assistance with any complex transformer issues. An engineer can provide expert advice and guidance. Ensure that all work on the transformer is performed by qualified and experienced personnel. This can help prevent accidents and ensure that the work is done correctly. Obtain all necessary permits and approvals before installing or modifying a transformer. This can help avoid delays and ensure that the work complies with all applicable regulations. Keep a copy of the transformer's documentation, including the manufacturer's instructions, wiring diagrams, and test reports. This information can be valuable in troubleshooting problems or making repairs. Regularly inspect the transformer's bushings for signs of cracks, leaks, or other damage. Replace any damaged bushings promptly to prevent failure. Ensure that the transformer's cooling fins are clean and free of debris. This can help maintain adequate cooling. Regularly check the transformer's oil level and add oil if necessary. Low oil levels can cause overheating and damage. Inspect the transformer's pressure relief device to ensure it is functioning properly. This device can prevent the transformer from exploding in the event of a fault. Ensure that the transformer's enclosure is properly sealed to prevent the ingress of moisture or contaminants. This can help prevent corrosion and premature failure. Regularly inspect the transformer's surge arresters for signs of damage or degradation. Replace any damaged surge arresters promptly to protect the transformer from lightning strikes. Keep the area around the transformer clear of vegetation and other obstructions. This can help prevent fires and ensure that the transformer is accessible for maintenance. Consider the potential for noise pollution from the transformer and take measures to mitigate it if necessary. This may include installing sound barriers or using a low-noise transformer. Regularly review the transformer's performance data to identify any trends or anomalies. This can help predict potential failures and allow for proactive maintenance. Consult with the transformer manufacturer for recommendations on specific maintenance tasks or intervals. The manufacturer may have specific expertise or knowledge about the transformer's design and operation. Ensure that all replacement parts used on the transformer are of the same quality and specifications as the original parts. Using inferior parts can compromise the transformer's performance and reliability. Keep a record of all transformer repairs, including the date, description of the repair, and the name of the person who performed the repair. This information can be valuable in troubleshooting problems or making future repairs. Regularly review the transformer's safety procedures to ensure they are up to date and effective. This can help prevent accidents and injuries. Consult with a safety professional for assistance with developing and implementing transformer safety procedures. A safety professional can provide expert advice and guidance. Ensure that all personnel who work on or near the transformer are properly trained in safety procedures. Training can help prevent accidents and injuries. Regularly inspect the transformer's grounding system to ensure it is intact and functioning properly. A faulty grounding system can increase the risk of electric shock. Ensure that the transformer's overcurrent protection devices are properly sized and coordinated. Improperly sized or coordinated overcurrent protection devices can damage the transformer or create a safety hazard. Regularly test the transformer's insulation to ensure it is in good condition. Insulation breakdown can lead to short circuits and equipment failure. Ensure that the transformer's ventilation system is adequate to prevent overheating. Overheating can damage the transformer and reduce its lifespan. Regularly inspect the transformer's cooling fans for proper operation. Malfunctioning cooling fans can lead to overheating. Ensure that the transformer's oil level is maintained at the proper level. Low oil levels can lead to overheating and equipment damage. Regularly inspect the transformer's bushings for signs of cracks or leaks. Damaged bushings can lead to equipment failure. Ensure that the transformer's connections are tight and free of corrosion. Loose or corroded connections can cause overheating and equipment damage. Regularly inspect the transformer's enclosure for signs of damage or corrosion. Damaged enclosures can compromise the transformer's safety and reliability. Ensure that the transformer's location is well ventilated and free of flammable materials. Poor ventilation or flammable materials can create a fire hazard. Regularly inspect the transformer's surroundings for potential hazards. Identifying and addressing potential hazards can prevent accidents and equipment damage. Ensure that the transformer's operating voltage is within the specified range. Operating the transformer outside of its specified voltage range can damage the equipment. Regularly monitor the transformer's load current to ensure it is within the specified limits. Overloading the transformer can cause overheating and equipment damage. Ensure that the transformer's harmonics levels are within acceptable limits. Excessive harmonics can cause overheating and equipment damage. Regularly inspect the transformer's neutral grounding resistor for proper operation. A malfunctioning neutral grounding resistor can create a safety hazard. Ensure that the transformer surge protection devices are properly installed and maintained. Surge protection devices can protect the transformer from damage caused by lightning or other voltage surges. Regularly inspect the transformer's lightning arresters for signs of damage or degradation. Damaged lightning arresters can reduce their effectiveness. Ensure that the transformer's connections to the electrical system are properly sized and installed. Undersized or improperly installed connections can cause overheating and equipment damage. Regularly inspect the transformer's wiring for signs of damage or deterioration. Damaged wiring can create a fire hazard. Ensure that the transformer's labeling is clear and accurate. Accurate labeling is essential for safe operation and maintenance. Regularly inspect the transformer's warning signs to ensure they are visible and legible. Visible and legible warning signs can prevent accidents and injuries. Ensure that the transformer's location is well lit. Adequate lighting is essential for safe operation and maintenance. Regularly inspect the transformer surroundings for signs of rodent or insect infestation. Rodents and insects can damage the transformer's wiring and insulation. Ensure that the transformer's maintenance records are complete and up-to-date. Complete and up-to-date maintenance records are essential for effective maintenance management. Regularly review the transformer's maintenance schedule to ensure it is adequate to meet the transformer's needs. An adequate maintenance schedule can help prevent equipment failures and extend the transformer's lifespan. Ensure that the transformer's maintenance personnel are properly trained and equipped. Properly trained and equipped maintenance personnel are essential for safe and effective maintenance. Regularly review the transformer's safety procedures with maintenance personnel. Reviewing safety procedures can help prevent accidents and injuries. Ensure that the transformer's safety equipment is readily available and in good working order. Readily available and properly functioning safety equipment is essential for preventing accidents and injuries. Regularly inspect the transformer's fire suppression system to ensure it is in good working order. A properly functioning fire suppression system can prevent a fire from spreading and causing extensive damage. Ensure that the transformer's fire suppression system is properly maintained and tested. Properly maintained and tested fire suppression systems are essential for effective fire protection. Regularly review the transformer's emergency response plan to ensure it is up-to-date and effective. An up-to-date and effective emergency response plan can help minimize the impact of an equipment failure or other emergency. Ensure that the transformer's emergency response personnel are properly trained and equipped. Properly trained and equipped emergency response personnel are essential for effectively responding to an equipment failure or other emergency. Regularly inspect the transformer's grounding electrode system to ensure it is intact and functioning properly. A properly functioning grounding electrode system is essential for protecting personnel from electric shock. Ensure that the transformer's grounding electrode system is properly sized and installed. A properly sized and installed grounding electrode system is essential for effective grounding. Regularly test the transformer's insulation resistance to ensure it is within acceptable limits. Insulation resistance testing can help identify potential insulation failures before they occur. Ensure that the transformer's insulation resistance testing is performed by qualified personnel. Properly qualified personnel are essential for performing accurate insulation resistance testing. Regularly monitor the transformer's operating temperature to ensure it is within acceptable limits. Operating the transformer at excessive temperatures can damage the equipment and reduce its lifespan. Ensure that the transformer's operating temperature is monitored using calibrated instruments. Calibrated instruments are essential for accurate temperature monitoring. Regularly analyze the transformer's oil samples to ensure they are within acceptable limits. Oil analysis can help identify potential problems with the transformer's insulation and cooling system. Ensure that the transformer's oil samples are analyzed by a qualified laboratory. A qualified laboratory is essential for performing accurate oil analysis. Regularly inspect the transformer's tap changer for proper operation. A malfunctioning tap changer can cause voltage fluctuations and equipment damage. Ensure that the transformer's tap changer is properly maintained and adjusted. Properly maintained and adjusted tap changers are essential for stable voltage regulation. Regularly inspect the transformer's core for signs of overheating or damage. Core overheating or damage can lead to equipment failure. Ensure that the transformer's core is properly grounded. A properly grounded core is essential for preventing circulating currents and core heating. Regularly inspect the transformer's winding connections for tightness and corrosion. Loose or corroded winding connections can cause overheating and equipment damage. Ensure that the transformer's winding connections are properly tightened and cleaned. Properly tightened and cleaned winding connections are essential for reliable operation. Regularly inspect the transformer's cooling system for leaks or other damage. Leaks or other damage to the cooling system can lead to overheating and equipment failure. Ensure that the transformer's cooling system is properly maintained and repaired. Properly maintained and repaired cooling systems are essential for reliable cooling. Regularly inspect the transformer's pressure relief device for proper operation. A malfunctioning pressure relief device can prevent the transformer from relieving excessive pressure, which could lead to an explosion. Ensure that the transformer's pressure relief device is properly tested and maintained. Properly tested and maintained pressure relief devices are essential for preventing transformer explosions. National Electrical Code 450.21 and 450.22 covers transformer ventilation. For Massachusetts, 520 Commonwealth Code of Massachusetts CMR applies.